As we move on with Chapter 10 and inheritance, we'll talk here in 10.3 about overriding superclass methods. That you can see here. This is on page 632. And what essentially we're saying is, hey, look, you might get via inheritance a bunch of things you did not want, and you should be able to, as the subclass, you should be able to decide for yourself what happens there, right? So this is something all of us at one point in time or another have said about inheriting, like our attitudes or something from our parents, or the sweet tooth or whatever else, right? We want to be able to override that. And that's exactly how overriding superclass methods works in Java. The subclass would specify to the runtime environment that do not go and ask my superclass how to do this. I tell you as the subclass how to be able to do this. This is achieved remarkably simply. This, as we continue on with 633, what we are looking for here is the idea that we want to override a superclass's method. So here you'll notice that a curved activity extends graded activity. So curved activity is our subclass and graded activity is our superclass. And this is for 634, just in case I said that with dyslexia, it's 634. And as we continue down here, you'll notice we have here, this is our class constructor, and as we continue down here we have set score. You'll notice that here we have the nomenclature that we're going to add to your toolkit here is the idea of this at override, lines 30 and 31, and this is the way that is structured. So on whatever the first line is, you have to at override, and then in the next line you would name this method exactly the same as you would do it in your superclass. So public void set score double S, that's going to have the same name, it's going to have the same return, and it's going to take the exact same number and type of parameters there. So if I was to scroll to a previous, it's not allowing me. But if I was to go back to 10.1 and look at graded activity, we would see that set score looks the same. This time around, we've got that idea of set score, but we need to take the idea of that curve and pass that along there. So here we're going to pass along to the super constructor the idea of set score, but this time around, instead of just your raw score, so that's what we would have passed along in the original method, we're going to override that, and we're going to include this times percentage piece. So we have successfully overruled, we have overridden the superclass's set score method by including this at override parameter there along with this. You'll notice the rest of these, get raw score, that's a new method, so we do not have to override anything. Get percentage, that's a new method, we do not have to override anything. And here with the constructor for our subclass, there's nothing to override because this is here with our subclass. That's handy for a whole bunch of different reasons. If we've got a vehicle class, right, and we've got a fuel reporting that we have to do on there, Some vehicles require miles per gallon, and other vehicles require mpge, right? The miles per gallon equivalent. So my lawn tractor does not have the same kind of miles per gallon as my battery powered lawn tractor does. They're just two separate things. So we would use this override for the idea of one gets miles per gallon, the other one gets miles per gallon equivalent. So we override that. Now, the very last thing included here in 10.3 override is the idea of overload versus override. They both begin with O. They both seem like they kind of derive from the same concept area. We have seen overloading in the past. That's when we have methods that have the same name but take different parameters. And you have all used that successfully, I think, to date, especially because it's been in the end of chapter program exercises. It's not the same thing as overriding. In overloading, we are still going to leverage the methods from the superclass without changing them. So we could have a calculation for integer, another calculation for double, and another calculation for floating point numbers. That's what we would do for overloading. For overriding, we would actually change the way we make that calculation. So, a cylinder can derive from a circle, but it would have a different calculation for volume in there. So we would have an override as opposed to an overload method for that. We're going to see an example of this in one of the coding demos that's going to follow.